All right, today we are going to take our speed, velocity, acceleration notes, or our SVA notes. You'll hear us say, or you'll hear me say SVA. That just means speed, velocity, acceleration. So what I did is I took page 12 in my notebook. Let's see if I can zoom it out some more. And I folded the whole page, and then I cut 2 lines so that I have 3 flaps. So right now all I have is 3 flaps. My notebook is straight up and down. It's not turned to the side. Folded the page, and I have 3 different flaps. So if I was you, I would pause the video now, and I would get your notebook set up like this. So fold your page in half, make 2 cuts, and you should have 3 different flaps, and we're doing it up and down, not sideways today. All right, once you have it set up, we are going to define these 3 words. You need to know how they are different. Each of these words has a very different meaning, and sometimes you confuse all 3 of them. So behind each flap, we are going to put the definition, and we're going to put an example for each word. So let's start with speed. I bet that most of y'all know that speed is how fast an object is moving. How fast an object is moving. And for speed, we use the formula, which you already learned this week, so this one isn't new. We use the formula speed equals distance divided by time. And you can measure, that's not very good. You can measure distance in meters, kilometers, miles, yards. Time could be in seconds, hours, minutes. So speed can be in a lot of different units. Let's do an example. All right, so our example is going to be about Bob every time. So Bob walked 2 meters in 10 seconds. What is his speed? Well, first we got to draw Bob. Oops. I'm going to try to draw Bob's arms, his hands on his hips. We'll see how this comes out. Let me give him a little hair first. And a smiley face. Okay, that's Bob. His hands are on his hips. So Bob walked 2 meters in 10 seconds. I always underline what I'm given. So I'm underlining 2 meters. I'm underlining 10 seconds. I always circle what I'm looking for. I'm looking for speed. So then, when I make my triangle, I know already that I'm looking for speed. I know that the distance is 2 meters and the time is 10 seconds. I know I will divide because they're on top of each other. So that means Bob's speed was 0.2 meters per second. So when you are given examples of speed, you have to have a distance, you have to have a time. What you're going to be asked to do is you're going to be asked to differentiate between speed, velocity, and acceleration. That means know which is which. That means you could be given an example in a word, a sentence, and you have to say, this is speed, this is velocity, this is acceleration. So you know it's speed if you have a distance and a time. All right. Let's go to velocity. I like velocity because it's very similar to speed. So velocity's definition is, let's put on this line, speed and a direction. How easy is that? It is just speed and a direction. We already said that speed is distance over time. But now we also have to make sure that we have a direction. So let's give ourselves a little example. Oops. All right, Bob again got a little more adventurous. He didn't just walk this time. Bob throws a baseball 100 meters west in 10 seconds. What is the velocity of the baseball? All right, so Bob, let's put Bob over here. All right, Bob. Give Bob a baseball cap because he's throwing a baseball. Oh, that's my baseball cap. And there's my baseball. Oh, that's a little rough. Let's give him a smile still. Bob's still got a big smile. Okay, Bob's throwing a baseball. So let's calculate what we need to calculate. It gave us 100 meters west. It gave us 10 seconds. It wants the velocity of the baseball. So we know that we can calculate this by finding the speed and just making sure we have a direction too. So your answer needs to be the speed and a direction. You're not going to actually add the direction. It's just a speed and a direction. So speed is distance divided by time. So 100 meters divided by 10. I should have put this in a triangle, but I don't have enough space. 100 meters divided by 10 seconds. I get that from the problem. So that means that the velocity equals 10 meters per second, because 100 divided by 10, west. So you do the same thing that you do for speed, but in your answer, you add a direction. So the speed of the ball is also 10 meters per second, but the velocity is 10 meters per second west. Velocity has a direction, not just a speed. So that's why we say velocity is speed and a direction. All right, last one. Acceleration. This one is one that's interesting because normally it's not what you think. When y'all think of acceleration, you think of going fast. You think of when a fast car gets on the highway and presses all the way down on the gas and goes fast. But there's actually 3 different forms of acceleration. One of them is speeding up. So going fast, that is a form of acceleration when you speed up. Another one is when you slow down. That's called deceleration. Deceleration is when you slow down. And the last form of acceleration is when you change directions. So acceleration is a change in speed. Whether you speed up, you slow down, or you change direction. That's the 3 ways that you can accelerate. So let's write our example. All right. Bob was walking home peacefully when an angry dog began to chase him. He had to run for his life. So Bob was just walking home nice and peacefully when an angry dog started chasing him and he had to run. I don't think I can draw a dog. This is going to be interesting. All right, let's say, oh goodness. Oh goodness. Oh, that turned out worse than expected. Too bad I can't erase. It is what it is. There's Bob running home. So what you should notice is we didn't do any math. We didn't solve anything. For acceleration, you're not going to solve anything. You just need to know the definition. It is speeding up, slowing down, or changing direction. So Bob had to speed up. He was walking home. He had to speed up and go a lot faster. So he sped up. That's one of the forms. Another thing that you need to add because you need it is the units. The units for acceleration are always going to have a squared. So it could be miles per hour squared, meters per second squared, yards per second squared, but it's always going to have a squared. So remember, I said you're going to be asked to differentiate between speed, velocity, acceleration. So if you are given a speed, the units will be meters per second. If you're given an acceleration, the units will be meters per second squared. That's one easy way to differentiate. If you are given a sentence that doesn't have any numbers, it just describes speeding up, slowing down, changing direction, that's acceleration. If it is a speed, you have to have a distance and a time. They could say an example of speed in 2 ways. They could say Bob walked 2 meters in 10 seconds. That's a distance and a time. Or they could say Bob walked at a speed of 2 meters per second. Both of those are an example of speed. If you are given a velocity, you will have a speed, but you will also have a direction. That direction should give you your answer. Whenever you see up, down, east, west, north, south, you know that it's velocity because there is a direction. So, final review. Speed is distance and time. Velocity is speed and a direction. Acceleration is speeding up, slowing down, changing directions. All right, so I know this video is kind of long. I wish you would have joined Zoom, and then you wouldn't have to watch this video. I would have done the notes with you. But anyways, your next assignment is going to be deciding whether examples are or statements, sentences, or pictures are an example of speed, velocity, or acceleration. Use your notes to decide. Make sure that if you choose velocity, there is a direction. Make sure that if you choose acceleration, it's in meters per second squared, or it says speed up, slow down, change direction.